Okay guys, so in this video we're going to be talking about adding and subtracting functions algebraically. So one of the videos that I have up here is adding and subtracting functions graphically, so just using graphs. This one is adding and subtracting functions with algebra. So that means that we're going to have basically 3 steps that you've done before. So it's nothing new. It's just that we're going to be adding the notation of functions to be able to solve these problems. So the objective is add or subtract polynomials of high degree by using function notation. These are the steps. So polynomials basically means many terms, right? So we're going to have more than one term. High degree means that you can have multiple powers. So you can have power 2, 3, 4, 5, 6, 7, whatever power they really decide that they want to use. And we're using function notation, meaning that function notation, we could have 3, 4, 5 different functions, and they could give you 1,000 different problems if they really wanted to based on those functions. So as I said earlier, the steps are the following. And none of these steps are new to you. You should be able to do them all already. So the first one is substitute the function into the corresponding values. Do the distributive property. If there's any numbers in front of the parentheses or in front of the function, you have to distribute the whole entire number to every single term inside of the function. Step 3 is to combine like terms. So group all the numbers that belong together. Remember, to combine like terms, for them to be like terms, they have to have the same variable or same variables and the same exact powers for them to be like terms, or no variables at all. Lastly, organize them from highest power to lowest power to be able to get your final answer in the correct one. Okay, so I'm going to give you just a little quick run through on how to do this. So I have 4 different functions. I have function f of x, which I just made up, 5x plus x to the power 4. G of x is 3x to the power of 4 plus 4x. K of x is 5 plus 7x to the power of 3 plus 3x squared. And then R of x is negative 12 plus 5x plus 6x squared. So these are 4 totally distinct functions. They all have different names. This is the function f, function g, function k, function r. Okay, now using those 4 functions, we're going to have 2 examples. Example number 1 is going to tell us that we have to find f of x minus g of x. Example number 2 is going to tell us you need to find k of x minus 2 times r of x. Now there's a reason why I color-coded this for you guys, so you guys can understand where I'm getting these numbers from. So the first one says we have to find f of x minus g of x. Well, that means that we're going to be substituting the value of f of x into this formula and then subtract the value of the function g of x and then by following the steps accordingly. Okay, so we're going to be plugging into this. If you guys would like, we're going to be doing one and then we can work on the other immediately afterwards. So we'll come back to this one. So find f of x minus g of x. So let's get to it on that one. So f of x minus g of x. We're going to plug in the value of f of x, which if you remember, f of x was equal to 5x plus x to the power of 4. So we're going to have 5x plus x to the power of 4, which is the value of f of x. This came from this. Now we're going to subtract function g of x, which happens to be this, 3x to the power of 4 plus 4x. So what this is saying is, if you take this function and subtract this function, what is the final result once you follow the steps that are above? So first step was substitute, done. So we plugged in the values of the function. Second step, distributive property. Is there any number that we need to distribute? Are there any numbers in front of the parentheses? Now you might think that the answer is no, but there's actually a negative 1 in front of this whole green parentheses here that I colored in front of g of x. So since I have a negative 1, I have to multiply every single term inside of the function parentheses by that negative 1. So this becomes 5x plus x to the power of 4, which I didn't mess with, right? I didn't do anything to this side. There's nothing in the front. And then when we distribute the negative 1 here, I get negative 3x to the power of 4 minus 4x. Don't forget to distribute the negative 1 into the 4x as well. All right, so we have this now. So step 1 done, step 2 done, distributive property. Step 3, we have to combine like terms. Do we have anything that we can combine here? Well, the answer is yes. If you look at it, we have the same variable, same power here and there. So we have 5x and 4x that we can put together. We also have this one and this one that we can put together as well. So we have 5x minus 4x, that's 5x's minus 4x's, we have only 1x left, so this becomes 1x. And then we can do the other two terms, x to the power of 4 minus 3x to the power of 4. Again, in front of the x to the power of 4, there's a 1. They don't write it, but it's there, right? So that's 1x to the 4 minus 3x to the 4. We have to subtract them because they're opposite symbols. That gives us a negative 2x to the power of 4. And we are technically done. Now, if you remember the last step says organize them from highest to lowest exponent. If you were to look at this in any multiple choice exam or in any textbook, you would not be able to find this exact answer because they put it in order from highest power to lowest power. So your final answer should actually be written like this: negative 2x to the power of 4 plus 1x. Now this says the exact same thing that we had before, but it is actually considered in simplest form and correct mathematically. Okay, so you want to put it at the end from highest power to lowest power for every single polynomial. All right, hopefully that was clear. Let's move on to one more example, and then you guys should be good to go. So the example number 2 says we have to find the k of x, function k of x, and then we're going to subtract 2 times the value of rx. Now, I color-coded this for you guys again. So k of x, we're talking about the yellow function that I colored up there. And then rx, we're talking about the red function that I colored up there for you guys. So we want to first substitute. So we're going to plug in everything that we see for k inside of my equation. So that's going to be the 5 plus 7x to the power of 3 plus 3x squared. So that is my function k of variable x. Now I want to subtract 2, so minus 2, multiplied by function rx. And if you remember, function rx is up here. So that's going to be negative 12 plus 5x plus 6x squared. Okay, so we did the substitution part. Done. Now, second step says we have to do the distributive property. Do we have any numbers inside of the parentheses? Well, not here, but we do here, right? So we have to distribute that. Now, make sure when you distribute it, you understand that there is a negative in front of the 2. So we're not multiplying by 2, we're multiplying by negative 2. Don't forget that negative. So bring down all the terms here. 5 plus 7x to the power of 3 plus 3x squared. Multiply everything here by the negative 2. So that'll give you a positive 24. That'll give you a negative 10x, and that'll give you a negative 12x squared. Don't forget the power is very important, that you keep the powers the same no matter what. So distributive property done. Can we combine like terms? We actually can in this case. If you notice, 5 can go together with 24 because neither of them have variables. Can anything go together with the x to the power of 3? Well, no, I don't have any more x to the power of 3, so I'm going to go ahead and skip that one. Can I put anything together with the 3x squared? And the answer is yes. This 3x squared can be grouped together with the negative 12x squared. And can I group this negative 10x with anything? Well, the answer is no. There's no other x's besides that one. So I'm going to bring down the ones that I didn't really use. I'm going to bring down the 7x cubed that I didn't mess with. And I'm going to bring down the negative 10x that I didn't mess with. Now I have to combine like terms for these guys. 5 plus 24, that gives me a total of 29, so plus 29. So those two came from this. Now I have to combine this one, 3x squared minus 12x squared. So that's 3 minus 12. Remember, we have to subtract those two. So that's 12, 11, 10, 9. So that gives me a total of negative 9. I say negative because the negative number is bigger. So this will be negative 9x to the power of 2. Okay, we're basically done. So k of x minus 2 times r of x is equal to this polynomial, 7x cubed minus 10x plus 29 minus 9x squared. However, mathematically is considered not simplified, so we got to put it from highest power to lowest power. So my final answer, I want to write it as 7x to the 3 because that's the highest power, followed by this one, so minus 9x squared, followed by this one, which is negative 10x, and then followed by the number without any variable. So my final answer would be this polynomial. Okay, I hope this video was helpful. I'll see you guys in the next one.